Hello, welcome to Code Design. Today we'll be solving Leetcode 49, which is group anagrams. So, what is anagram? So, anagrams we call two strings are anagrams to each other if they can be rearranged to form each other. So that means the character counts and the character would be same in both string, but they are in a different order. So let's try to understand. N A T net and ten T A N. So we can see that both of them has N A T and TAN, the same characters but different order. So if we sort it, it would be A, N, T, and it would be also, and if we sort the strings in alphabetic order. So, um, and another one is at, eat, and tea. So if we sort them, we'll get A, T, E, E, ATE, if we sort them lexicographically. So if we, and how about bat? Bat does not have any matching word that is anagram to bat because there is no other word having B. So the output it expects is a list of string. So fast list is having and the order can be any order, like these things could come fast, but we need to group the anagrams. So bat will be single, net and ten would be grouped as anagram, and at, eat, and t would be group of anagrams. So if we try to solve it, what comes to our mind? We need to sort it, right? Sort the words. So say 10, if we first get 10 and sort it, we get A and T. So we can use it as a key. If we use it as a key of a hash map, then what will be our values? Our value would be list of string. Cost we want to store the all the anagrams of that word. That means all the anagrams of at. And and finally we will output them. So what is the constants here? We have 10,000 strings at most. So these strings could be 10,000. If we say it m, if we say it n, then n would be 10,000. And what is the length, maximum length of each string? That would be up to 100. So if we call it m, then m would be n would be 10,000 and m would be 100. So when we use them as a part of key, right, or when you compare them, we need to sort. So what is the best sorting time complexity we can get? If m is the word length, so that would be m log m. To sort each of the word, it would be m log n m. So is max 100, so it would be like for sorting each word, it would be 100 log 100. So 100 and log 100 is 6.64. So basically 664. This is not the exact number to sort each word. So the word will be vary, if the length is 100, it will also depend on sorting algorithm and performance. Um, so this is to sort one word. So now we have how many words we have? We have max 10,000. So our n is 10,000. That means it will be n, and we have n words. That means 10,000 words. And for each word, we need m log m, n into m log m. That would be our time complexity. And what would be the space complexity? We'll be using HashMap. So that would be our number of words. So up to n, which is 10,000 space, and any intermediate space, constant space during sorting. So we can ignore that one, and let's start the implementation. So we first define the hash map. It would be a okay, map of uh, util dot star map of string, list of string, map, new hash map. Okay, we create the object of hash map, and so initial list of string will be null. So when we create the hash map object, and key would be also null. So and we have this string array. So we look through the array string strs, and for each of the string we convert the string to a character array, so that we can sort it using arrays dot sort ch. So after we sort the word string key new string ch. So you could also use string dot value of ch, which might be more readable, but is the same efficient as new string, because string dot value of also call this new string internally. So we create the key, and then in the hash map, right? If in the map dot contains key, map dot contains key, what we do? We get map dot get key. We get the list and add this string to that list. And what if the map doesn't contain the key? So initially the map will not contain anything, right? Null. So what we'll do? we need to create list of string, uh, list, new array list. We need to create an array list object, and list dot add. We need to add the string in the list, and map dot put key, and value would be our list. So that is initializing it for the first string. So when we have it, so it is add, basically the key is add, the value is eat. And for this thing, we'll sort the key, which would be ate at, and then we'll create a list object, a list object, add the string eat, and the key is at, right? Because we sorted it. We'll put it in the HashMap. And next time, when we'll have t, then again we will sort the key. So key would be same as at, but the value is t. So we will get it here because we already have the key at here. So we will get the list and add t there. So this is how it will work. And finally, when we have it, we'll come out of the loop, and the hash map will have now all the anagrams grouped. So what is the easiest way to get the values of the map, right? Return new array list, map dot values. So we have this function map.values that return all the values of the hash map. So what's our values is basically a list of string. So the map.values will return a collection of string. But what is our return type is list of string. Well, a list is also a collection, but you cannot just return map.values. You will get error because it's a collection of string, but you can create a new arrays object by passing this collection of list of string. So that will give you a list of string. So this is our implementation, and let's see, run it, and if there is any compilation error. Okay, so there is no compilation error. It's good. Now there is so it passed the initial test cases, empty, it passed. Okay, it passed. So one, if we look at this, one thing we can do, we can now that we wrote it. So when you will be initially doing it, if you are comfortable with old style of coding, I'm comfortable with doing this because sometimes you might not know the syntax for streams, or yeah. So we can actually concise it and by writing this map dot compute if absent, and then we put the key and for the values, right? So what it does, compute if absent, it gives you the value if the value exists, if the value is non-null, and if the value is null, it takes a default value as a argument, as a function. So that's why we need to use the lambda expression here to create an empty array list, because it takes a function here. You cannot just pass new array list here. So what it will do, it will basically return if uh, for a key like net or and if it's already exists, it will return the array list, and if it's not, it will create a new array list and then return it. So here what you will get a list of string, right? Because it returns the value for the key. List of string, another list, uh, str. Then you can add your string, list of string dot add. So why to unnecessary just create a list of string here? It was just a demonstration. I just wanted to see what it returns. So add str. So you can replace this one with this compute it absent key L new array list. Okay, let's run this. Okay, it worked. So now that it worked, I'm going to clean it up. So this is our final code. Not is small line, like less than 6-7 lines. So this is our final code, and we can submit it now. Okay, it accepted, got accepted. it beat 63.82% of other submissions for time complexity, and the space complexity it has is 50. It also beats 57.67%. So